Hey guys, welcome back to my channel, and in today's video we are going to solve one more LeetCode question, that is question number 543, diameter of binary tree. This is an easy level question and it has been asked by these many companies in last 2 years. So let's see what this question is all about. So in this question we are given a root of binary tree and we have to return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. So if diameter is the length of the longest path between any two nodes, it is possible that that path may or may not include root. And the third thing is that the length of the path between any two nodes is represented by the number of edges. So if we see this example where there are 1, 2, 3, 4, 5, these are the nodes of a tree. And if we see the diagram, we can clearly see that the longest path is 4 to 1, 3 or 5 to 1, 3 because the length is same, so we can take any one of those paths. And we can see that there are 3 nodes connecting all the 4 nodes, 3 edges connecting all the 4 nodes. So let's try to understand even better this whole question using this example. So if we have to understand with what approach we can solve this whole question, then we need to start with the smallest structure of the binary tree. Like in binary tree, we all know that there is one parent and at most there are 2 child, that is left and right. So rather than starting with this huge tree, let's try to understand with this a small tree. So if this was the tree and I have to calculate the longest path, what would I have done? So I would have simply taken the left path length and right path length, and I would have added both of them, and in this way I would have calculated the length of the whole tree, right? Left path and right path. But suppose if this tree is extended in this way, then what I would have done? I would have simply taken the max of left and max of right and added up. The same thing we are going to do for this question as well, where for every node we are going to check the left path and right path, and we have to take the max of it and then add it up and calculate the longest path. So let's see how we can do it. So as we have understood that we calculate longest path by adding up the left and the right length, but as the tree is not that short, we need to consider the max of left and max of right. So if we follow that approach, then for this root node, firstly what we will be doing, we will be calculating the left max. So if I'll see the left max, I can see that 2, 5, 7 or even 6 can be taken rather than 7. Any of these paths will give us answer equivalent to 3, right? And 3 and this length will be 1, so it will give 4. So the longest path from this node, which is root, is 4. But I will then proceed towards this node and I will check the same thing. So I will again do the same procedure and I will again perform the same calculation and analysis, and I will calculate the left path, and then I will again do the same thing for right and calculate both of them, take the max, add it up and find the longest path. So we know that we have to find the max of both the paths, but if we are coming from top to bottom, we can see that we are repetitively calculating for the same path again and again, even though this node was even included in the previous calculation when we did for the root, right? Again we are performing the same operation for this node, and then we are again doing the same thing for this node and every node. So this is repetitive work. So this is going to increase our time complexity. It is going to make it bigger of n square. So rather than increasing our time complexity by approaching this solution in this manner, what we can do is we can go from bottom to top, right? Rather than coming from top to bottom, we can go to top from bottom. And for this we can also use DFS. So we can use bottom up DFS. Why DFS, not BFS? Because DFS will allow us to directly dive deeper and calculate the length, because that is what we are trying to find. But with BFS we won't be able to directly find the maximum length. So we are considering DFS, and that even bottom up DFS, and we will recursively call this analysis function or the condition checker function, in which we are checking whether this node is having the max left or max right, and with which value we need to proceed, and all these things. So we will use a recursive approach for that. So let's just try to analyze that recursive approach. So let me make you understand what that recursive approach is. So firstly we will go to this root and we'll be like, what is the max left and max right? Right? So we will come to this stage. Then we are like, for this node again we have to do the same thing, max left and max right. So in this manner we will reach up to bottom, that is the leaf node. And at leaf node we can see there is no further node, right? So max of left and right will be 0 for these nodes. So this will be 0. But when I am going to return this value to 5, what I will do, I will increment 1 in these values. So what I'm trying to say is, once we calculate the max of left subtree and right subtree, or left path and right path, we will add 1 into it. Why we are going to add 1 into it? Because if we see what we are checking here, we are checking path, correct? We are checking path, and we know that after this node there is no further node, so there is no path or no edge after this node. That's why its value is 0. But when I'm returning this value back to this node, parent node, I know that parent node will have parent node is having a edge from 5 to 7, right? And we have already seen this thing in question, that the length of the path between two nodes is represented by the number of edges. So if we see, when I'm returning value from 7 to 5, there is one node, and according to this, the path or the length from 5 to 7 is equivalent to 1. But as I calculated for 7, it's 0. So what I will do, I will simply increment 1 and return it back to parent. So at every step, this is something we are going to do. So this is the formula that we will be using, where firstly we are calculating the max of left path and right path, and after finding out the value we will increment 1 and return it back to parent. So for 6 as well we will do the same thing, that is 0 plus 1, right? 0 plus 1, so it will also return back 1 to 5. So this 5 will be having two values, left is also 1 and right is also 1. So again we will do the same thing, we will take max of left and right, so it is 1, and we will add 1 into it, so it will become 2, and then this 5 will return 2 to this node, that is 2 node. So what 2 will get? 2 will get its right value equivalent to 2, and its left value is 4. Where for 4, when we are going to calculate, it will be like 0, and again we will increment 1, so this will return 1. So 2 will get 1 and 2 as left and right path. So when 2 is going to take max of both of them, it will take 2 and again add 1 into it and return it to this root node. So what root node will get as the left path? It will get 3, and for right path, root node will get 0 plus 1, right? Same thing, leaf node, so it will return 1. So root node will get 3 and 1 as what? Left and right path, and it will take max of it, that is 3, increment 1, and this is what our answer is. It is equivalent to 4. And if we see the diagram, we can clearly see that 6, 5, 2, 1, 3 of 75213. This is what the answer is. So let me just highlight these nodes which are answer so that it would be clear to everyone. So this is 3, this is 1, this is 2, this is 5, this is 7. We can consider 3 as well, but I'm just highlighting 7 so that no one will get confused. So this is the path, and we can see there are 1, 2, 3, 4 edges, and our answer is also 4. So this when we are performing DFS, that is bottom of DFS, its time complexity will be around big O of n, and space complexity will also be around big O of n. Why? Time complexity, as we are visiting every node in order to check the longest distance, longest path, so it will take big O of n time. And because we are using recursive calls, so there will be a recursive stack or a call stack which will occupy big O of n space in worst case. So for that, space complexity is going to be big O of n. So this was the whole approach, where this is our function that we'll be using for calculating the longest path. And now let's just quickly code this solution, and we will be coding in 2 languages. So let's firstly do in Python. So this is diameter, because that is what we will be returning. So let's initialize it with 0. Then we will define a function which will be longest path, and we will be passing node inside this function, and we will check if there is no node, then return 0, right? And if there is a node, then check its left subtree. Left subtree will also be longest path, and node dot left, then right subtree, that will be longest path, node dot right. And once we have calculated these 2 things, we will update our diameter. So non-local diameter, so that we will be able to access it, and diameter will be max of diameter and left subtree plus right subtree. Once our diameter is updated, so if the value is going to be greater than the existing path, then only we will update it, else we are not going to update our diameter. And at the end, we will be returning the same thing that we saw in our explanation, that is 1 plus max of left subtree comma right subtree. And this is it for this function. After this, we need to call this function, because this is our DFS function, so we need to pass our root node. So this is the longest path. Inside this, we will pass our root node, and then at the end we will return the diameter, because after all the calls it would have been updated. So now let's try to run this. Now let's try to submit this, and we can see this is accepted. Runtime is memory, both the things are random, so we don't have to focus on that because we have already discussed the time and space complexity. So now let's quickly code Ruby solution as well. So in Ruby as well, we will do the same thing. Firstly, we will create our instance variable, initialize it with 0, then create a function as longest path. Inside this, we will pass a node, and then inside this function, we were checking if node dot nil is true, then return 0. This is the 1-line syntax, and if not, then check its left subtree. I'm fumbling a lot. And in this as well, we will call longest path, that is node dot left. right subtree. This is going to be longest path, node dot right. And after calculating this, we are going to update diameter, which will be max of diameter and left subtree plus right subtree's path length dot max. And after updating diameter, we will return 1 plus left subtree and right subtree's max value, correct, dot max. And after this, we'll step out of this function, call this function, pass root inside it, and return diameter at the end. That's it. Now let's quickly submit this and check. Okay, I made a mistake somewhere. Oh, here I forgot to put that @ sign. Now it will work, I guess. Yeah. So it's also accepted and submitted. So this was the whole solution and explanation, and I hope this video was helpful for you all. And if you really find it helpful, then don't forget to like, share and subscribe my channel, and I will soon come up with more such questions. Till then, keep messing with algorithms, and thanks for watching.